sometimes we can come across with integral where on top, let's say, it's 4x minus 5, and at the bottom it's something of power 3, let's say x times x minus 2 squared. I have already factorized the bottom for you because it can be even in terms of one polynomial, and you need to make those factors. For example, when the bottom initially is written as x cube minus 4x squared minus or plus, let's say, 4x, you need to factorize it first, so you need to pull out x, and it will be x times in brackets x squared minus 4x plus 4, and then you may use the formulas of simplified multiplication to understand that this thing actually will be x minus 2 squared. But so far so good, we have factorized it, or we have been given already factorized expression. But what to do with it? Again, you can see that the top is power 1 polynomial and the bottom is power 3 polynomial. If you take derivative of the bottom, you will get something polynomial power 2 and will not get polynomial power 1 as we are given. So we need to do something else with it. And here is where partial fractions come to play again. We may divide it into the following fractions. So we can say that we have a over x. However, the second root is repeated. What to do with it? Well, one of the ideas is just to write plus b x minus 2 squared, and that's all. But it does not work this way, because in order to get something nice on top, like to identify in the unique way a and b, you need the third fraction, which is c over x minus 2 already without any power. So if you have repeated root, you are likely to have to write 3 fractions. The good news is that in many exercises you will already be given those denominators, and therefore you will need just to find a, b, and c, and don't bother with finding the appropriate denominators. But not always, sometimes you'll have to. So how to find a, b, and c? Well, the idea is the same, so that a needs to be multiplied by something to bring all of that to common denominator. Same as b and same as c. However, in this case we do not need to multiply by all denominators. It is just enough to multiply a by x minus 2 squared, b by x, and c by x and then x minus 2. Why is it like that? Because obviously the common denominator must be x times x minus 2 squared, and you need to look what else is needed in the fraction. For example, this fraction has x in denominator, but you need to have x times x minus 2 squared, so you need to multiply it by x minus 2 squared. This fraction lacks only x, so we're multiplying it by x. But that fraction, the third one, doesn't have x minus 2 to make it squared, and it doesn't have x, so we have to multiply it by both of them. So a times x minus 2 squared plus bx plus c times x minus 2 should be equal by analogy to the top or to the numerator of initial fraction, which is 4x minus 5. And And here we have 3 letters and only one equation. What to do with it? Thankfully the answer is not so difficult, and again, like in the previous case, we need to substitute such x that will make some of the fractions be 0. Here obviously x equals 2. If x equals 2, we can say that the first bracket will be 0, the third bracket will be 0, and we can write that b times 2 equals, and we need to substitute 2 on the right side as well, 4 times 2 minus 5. So it will be 2b equals 8 minus 5, which is 3. From here b will be 3 over 2. Nice. Second part, or second stage, we want to make sure that x is 0. We substitute x 0, bx gets out of the way, the third term again gets out of the way, and the only thing which is left is a, which is a times minus 2 squared equals 4 times 0 is 0, so equals minus 5. From here a, or 4a first, will be minus 5, so a will be minus 5 over 4. And that's we found a. And this is where the questions start of people, but how to find the third one. Because whenever we put something to eliminate a or b, c gets cancelled out anyway. And the answer is simpler than you think. Plug any x which is not 0 and which is not 2. And you will have also to plug known already a and b, and the only unknown will be c. Let's see how to do it. Well, let's imagine that x now is 1, because it's a good value. It's easy to calculate everything when x is 1. So when x is 1 and a is minus 5 over 4, so we're getting minus 5 over 4 times 1 minus 2 is minus 1, so then minus 1 squared will be 1, so times 1 plus bx, and b is 3 over 2 times x, which is 1, and then plus c, which is not known, times 1 and times minus 1, because 1 minus 2 is minus 1. So it will be minus c, in fact. So minus c will be 4x minus 5. When x is 1, it will be 4 minus 5 equals minus 1. So what do we have here? We have the only very unknown variable, which is c. So c equals, let's shift it to the other side, minus 5 over 4 plus 3 over 2, and then plus 1. So 1 we shift to the other side. So that is your c. Now you can use the calculator. Minus 5 over 4 plus 3 over 2 plus 1, and you get 1.25 or 5 over 4. So c equals 5 over 4. Nice. Therefore we can rewrite this whole fraction into 3 simpler fractions where a is, where do we have a, minus 5 over 4, minus 5 over 4 over x, then b, which is 3 over 2, so plus 3 over 2 x minus 2 squared, and then plus c, so plus 5 over 4 over x minus 2. And now we can solve that integral because it can be decomposed, it can be broken apart into three integrals. Each of them is easily solvable. For example, the first integral will be ln x, because we can put minus 5 over 4 outside, and it will be integral from 1 over x dx. The second integral, again 3 over 2, can be put to the other side or outside of the integral. We will have 1 over x minus 2 squared. And then the third integral will be 5 over 4 integral of 1x minus 2. Of course, everything dx. I'm sometimes skipping those dx's for the sake of saving time, but ideally you must write it. So now what is what? The first integral is just ln x, ln modulus x, because we have learned during lecture 2 that it is ln. The third integral on top is derivative of the bottom, so it will be just ln x minus 2 modulus. Of course, coefficients in front go with the result. But we have the middle integral, which is a bit more difficult to solve since you have square here and you cannot say that on top this is derivative of the bottom. So a small note on how to solve those parts. Well, 1 over x minus 2 squared can be written as x minus 2 power minus 2. And then this whole thing can be coped with using the normal rule of integral. So integral of that thing, dx, will be the same as x minus 2 power minus 1, so power is raised by 1. And then we divide it by the new power, so we divide it by minus 1 is the same as multiplying by minus 1. So therefore the middle integral can be written as 3 over 2, then minus times minus 1 times x minus 2 power minus 1, and plus c at the end of the whole thing. The good news is this is probably as difficult as it can get at a level with tasks involving partial fractions. Now, as the final step, I can write, instead of plus, minus in front of the fraction and remove this minus 1 out of the way. Or even to make it more beautiful, this whole thing can be rewritten as 3 over, I will move it here, as 3 over 2 times x minus 2. And that's how I would leave it as in the answer. That's it for today. I hope you enjoyed this video and you've learned something useful for you. If you did, subscribe, put that like button, and I'll see you in the next video. We will talk about integration by parts pretty soon. Have a nice time. Bye bye.